Could they help us understand how reality, space, and time work at a deeper level? Black holes are fascinating because of a concept called the event horizon. This is a boundary where we think we have full control over physics. We understand what's happening there, but there's a problem. Two fundamental theories of nature, quantum theory and general relativity, don't fully fit together. The challenge of combining these two huge ideas of 20th and 21st century physics is called the quantum theory of gravity, and it's considered by many as the ultimate goal for theoretical physicists. In this sense, black holes push us to think deeper about space and time. They are, in a way, the key to understanding the universe. I'm Brian Cox, a professor of particle physics at the University of Manchester and the Royal Society Professor for Public Engagement in Science. I'm also the author of the book Black Holes, The Key to Understanding the Universe. The idea of black holes goes back a long way, all the way to the 1780s and 1790s. Two thinkers from that time, one was a clergyman named Mitchell, and the other was the great French mathematician Laplace, independently had a similar idea. They both thought about the concept of escape velocity. Escape velocity is the speed you need to escape the pull of gravity from a planet or a star. For example, on Earth, the escape velocity is around 8 miles per second, while on the Sun, it's about 400 miles per second. The escape velocity increases with the mass of an object, since gravity is stronger on bigger objects. Mitchell and Laplace had an interesting thought. They imagined even larger and more massive stars where the escape velocity at the surface would exceed the speed of light. If that happened, the star would be invisible. You wouldn't be able to see it. To understand why black holes are so puzzling, it's useful to think about what a black hole looks like. From the outside, there's an event horizon around the black hole. This acts as the boundary between the external universe and the inside of the black hole. If you cross this boundary, even traveling at the speed of light, you can't escape the black hole's pull. Another confusing idea about the event horizon is that, when viewed from the outside, it seems like time stops there. This is a prediction from Einstein's theory of relativity. But even though we can picture the event horizon, a huge question remains. What exactly is at the center of a black hole? Some think it might be an infinitely dense point, a place where a massive star collapses. This is what's called the singularity. But it's not accurate to talk about the center of a black hole in normal terms. According to general relativity, when you look at a map of a black hole, a so-called Penrose diagram, you see that space and time become so distorted that they seem to switch roles. The singularity is not really a place in space, but more like a point in time, and it's actually the end of time. For many years, scientists didn't know what to make of this mystery. They thought that maybe we couldn't explore the singularity, and that it might remain unsolved for a long time. Then a breakthrough came. Stephen Hawking showed that there are problems not just at the singularity, but also at the event horizon. When quantum theory is applied near the event horizon, black holes seem to glow. They give off particles and have a temperature. This was surprising because in Einstein's theory, black holes were purely geometric and just distorted space and time. But with Hawking's theory, they emit particles, a phenomenon known as Hawking radiation. Hawking described this in a paper in 1974, suggesting that near the event horizon, particles constantly appear and disappear. Some of these particles can escape into the universe, taking energy from the black hole, which causes the black hole to shrink. Eventually, the black hole would vanish. This idea has profound consequences. Black holes aren't forever. They have a lifespan, and eventually, whatever's inside them is released back into the universe. But there's still a major question. What happens to everything that falls into the black hole? According to Einstein's theory, it would all end up in the singularity, a mysterious point at the end of time. But then, after the black hole disappears, all that remains is a Hawking radiation, the particles emitted by the event horizon. Here's where it gets interesting. Is it possible that the information about everything that fell into the black hole could be found in the Hawking radiation in the distant future? This question, called the black hole information paradox, is still up for debate. If you could collect all the Hawking radiation from a black hole's entire life, could you reconstruct the information about what went into it? This is important because, in physics, we believe that information is never lost. So even if you destroy something, in theory, you could rebuild it if you collect all the energy and particles that were involved in its destruction. For a long time, people thought that black holes might break this rule and erase information from the universe. But now, scientists think that black holes don't erase information after all. In fact, it seems it could gather all the radiation and use it to rebuild what fell into the black hole, possibly with quantum computer. The implications are huge. This discovery gives us a glimpse into a deeper theory of gravity. It suggests that space and time might not be fundamental. Instead, they could emerge from something deeper, perhaps from quantum entanglement, although we don't yet know what that something is. This idea, known as emergent space-time, is at the cutting edge of research. It suggests that space and time themselves are not the fundamental building blocks of reality, but emerge from something else. This new theory might just be the quantum theory of gravity that could explain the true nature of the universe. In my view, before we can even begin to answer big questions like whether the universe had a beginning, we need to first understand the true nature of space and time. Black holes are forcing us to confront these questions and are leading us to new ideas about the universe. As Einstein once said, if we keep digging into nature's secrets and follow the clues, we might catch a glimpse of something profoundly hidden. Something beautiful, the true underlying structure of nature. It's an exciting time in physics, and although we don't know where it's going, we're starting to see the first hints.